Good morning, students. Now we discuss about the exercise 8.7. So see, homogeneous function and Euler's theorem. Now we discuss about the homogeneous function and Euler's theorem. So f is a homogeneous function. That means subdivision 1, first one. Now I define the homogeneous functions. Homogeneous function means f of lambda x lambda y equal to lambda power p into f of x comma y. That means that suppose they give one function. So we substitute x equal to lambda x and y equal to lambda y throughout the functions. So after that we get back lambda power p into f of x comma y. So this format, the right hand side format we get. So from this we tell it is a homogeneous, or otherwise f of lambda x lambda y lambda z equal to lambda into f of x comma y comma z. So we call p is called a degree of f of here. That means lambda power p will come here, p will come. So that means f of lambda x lambda y lambda z equal to lambda power p f of x comma y comma z. So p is called the degree of p is called the degree of f. Next, f is homogeneous on A with degree p. Then suppose f is homogeneous with degree p means further we proceed. That means x into dou f by dou x plus y into dou f by dou y equal to nf. This is the Euler's equations. This equation we call the Euler's equations. X into dou f by dou x plus y into dou f by dou y equal to nf. So homogeneous means the condition is f of lambda x. We substitute x equal to lambda x, y equal to lambda y. So the equal to lambda power p into f of x comma y. Then p is the degree of the equations. You see here. Now we discuss about the exercise 8.7. The first question: in each of the following cases, determine whether the following function is homogeneous or not. This is so. If it is so, find the degree. So that means in each of the following cases, determine whether the following function is homogeneous or not. So here we find out the homogeneous or not. If it is so, find the degree. Suppose it is homogeneous, we find out the degree. So subdivision 1, f of x comma y equal to x square y plus 6x cube plus 7. This is a function. This is our given function. Now we check it the homogeneous or not. So we substitute. We take the function f of lambda x lambda y. That means we substitute x equal to lambda x, y equal to lambda y. So I substitute in the functions x equal to lambda x, y equal to lambda y. So lambda x whole square into lambda y plus 6 into lambda x whole cube plus 7. So in the next step, lambda square into, that means lambda square into x square lambda y. So lambda cube into, here x square will come, x square y. So lambda cube x square y plus next lambda cube 6x cube plus 7. You see lambda cube not common in the all the terms, because first term lambda cube, second term lambda cube, but no lambda cube in the third term. So we are not able to take the lambda cube in the outside. So from this, so we cannot take lambda cube outside as common. Therefore the given equation is not homogeneous. The given function is not homogeneous, because f of lambda x comma lambda y means we form the equation lambda power p into f of x comma y. We take the lambda values from the outside from this factor. So we are not able to take the outside lambda cube, we are not able to take outside. So because lambda cube not common in the all the terms, therefore it is not homogeneous. The given function not homogeneous. This is the conclusion. Next, second functions, h of x comma y equal to, that means 6x square y cube minus pi y power 5 plus 9x power 4y by 2020 x square plus 2019 y square. You see the equation is 6x square y cube will come 6x square y cube minus pi y power 5. Here 5 will come. So 6y is, that means 6x square y cube minus pi y power 5 plus 9x power 4y by 2020 x square plus 2019 y square. So here that means h of lambda x comma lambda y. You see x equal to lambda x, y equal to lambda y. So we substitute here. That means x equal to lambda x, y equal to lambda y means here 6 into lambda square x square y cube. Here y cube will come. So lambda cube y cube minus pi into here y power 5, not 3, y power 3 not, y power 5. So y power 5 means lambda power 5, y power 5. Here next plus, here plus will come, plus 9 into lambda power 4 x power 4, y means lambda y by 2020 lambda square x square plus 2019 lambda square y square. You see, that means h of lambda x comma lambda y equal to, you see here, that means lambda square lambda cube lambda power 5, 6 lambda power 5 x square y cube minus pi lambda power 5 y power 5. Next plus, here plus will come, plus 9 lambda power 5 x power 4 y. So you see every terms lambda power 5 is common. So I take the that means here the common in the numerator. So I take the lambda power 5 in the numerator, in the denominator lambda square common. So lambda power 5 by lambda square means lambda, numerator lambda power 5, denominator lambda square. So the lambda square and lambda power 5 cancelled. The remaining lambda is lambda cube into, the remaining terms are 6x square into y cube minus pi y power 5 plus 9, that means plus 9 x power 4 y by 2020 x square plus 2019 y square. This is the h of x comma y. So lambda cube into h of x comma y. Therefore h of lambda x comma lambda y equal to lambda cube into h of x comma y. Therefore the degree is 3. Therefore h of x comma y is homogeneous functions. Its degree is 3 means the lambda power number is 3. So the degree is 3. Next third subdivisions, g of x comma y comma z equal to cubic square root of 3x square plus 5y square plus z square by 4x plus 7y. Now this is our given function. So now I substitute the g of lambda x lambda y, that means x equal to lambda x, y equal to lambda y, z equal to lambda z. So is square root of 3 into lambda square x square plus 5 into lambda square y square plus lambda square z square by 4 into lambda x plus 7 into lambda y. Therefore you see lambda square common in the every terms. So I take the outside lambda square, square root of lambda square is lambda. So I take the lambda in the square root. So lambda into square root of 3x square plus 5y square plus z square. Here in the denominator also lambda common. So I take the lambda in the outside. So lambda into 4x plus 7y. So lambda cancelled. Lambda power 0 into g of x comma. You see this is the given function. So I write it g of x comma y comma z into lambda power 0. Therefore g of lambda x comma lambda y comma lambda z, we write lambda power 0 into g of x comma y comma z. So we conclude that g is a homogeneous function. Its degree is 0. Next fourth subdivisions, u of x comma y comma z equal to xy plus sine of y square minus 2z square by xy. This is our given functions. So now we substitute u of lambda x lambda y lambda z equal to every, that means x equal to, we substitute lambda x, y equal to lambda y, z equal to lambda z. Now we substitute in the above functions. Therefore in the right hand side x, substitute lambda x. So I substitute lambda x, y equal to lambda y. So lambda x into lambda y means lambda square xy plus sine of y square means lambda square y square minus 2 into z square means lambda z whole square into x is the lambda x, y is the lambda y. So therefore lambda square xy plus sine of, that means you write it, the lambda square is common, I take outside. So lambda square into y square minus 2z square by, we write it lambda square into xy, lambda square cancelled. So we write it y square minus 2z square by xy. Therefore you see lambda square into xy plus sine of y square minus 2z square by xy. You see lambda square not common in the second term. There is no lambda square in the second term. So we cannot take lambda square in the outside. Therefore from this we conclude that it is, the function is not a homogeneous. So we cannot take lambda square outside the function as common. So u of x comma y comma z is not homogeneous because the no lambda square in the second term. Second question, second problem, prove that f of x comma y equal to x cube minus 2x square y plus 3xy square plus y cube is homogeneous. What is the degree? Verify Euler's theorem for f. You see here this is the given functions. So prove that is homogeneous. We will prove this one is a homogeneous, and they ask about the degree and verify the Euler theorem. So first write the given functions. F of x comma y equal to x cube minus 2x square y plus 3xy square plus y cube. The next step I write it. That means I take f of lambda x lambda y. That means x equal to lambda x, y equal to lambda y. I substitute in the above functions. So f of lambda x comma lambda y, x equal to lambda x, y equal to lambda y means just lambda x whole cube minus 2 into lambda x whole square lambda y plus 3 into lambda x into lambda y whole square plus lambda y whole cube. So in the next step, lambda cube x cube minus 2 lambda square x square lambda y. So next plus 3 into, here I substitute lambda x, y means lambda y whole square, so lambda square y square plus y means lambda y whole cube means lambda cube y cube. So in the next step you see this is a lambda cube x cube minus lambda square into lambda cube. So minus 2 lambda cube x square y plus 3 into lambda cube x y square plus lambda cube y cube. You see all the terms lambda cube is common, so I take outside. So lambda cube into the remaining terms are x cube minus 2x square y will come here, 2x square y second term y, 2 minus 2x square y will come here plus 3x y square plus y cube. So this is the lambda cube into this is the f of given functions. You see the given functions, f of x comma y equal to x cube minus 2x square y plus 3xy square plus y cube. This is our given functions. Therefore lambda cube equal to f of x comma y. Therefore f is a homogeneous function of degree 3. This is our, you see, so f of lambda x comma lambda y means we write it lambda cube into f of x comma y. So this is a homogeneous functions, the power is 3, so the degree is 3. So next we verify the Euler's theorem. We know that Euler's theorem means x into dou f by dou x plus y into dou f by dou y into pf. That means pf means here p value is p equal to, that means nf means here the power is we take the n equal to 3, so I substitute 3f. Now we verify, we substitute the dou f by dou x equation, dou f by dou y equation. So first I calculate the dou f by dou x. Dou f by dou x means here f equal to x cube minus 2x square y plus 3xy square. Now I differentiate with respect to x on both sides. So dou f by dou x equal to x, differentiation of x cube is 3x square minus 2y into differentiation of x square is 2x, so 4 minus 4xy plus next 3y square constant, differentiation of x is 1, so plus 3y square. Therefore dou f by dou x equal to 3x square minus 4xy plus 3y square. Next I multiply x into dou f by dou x equal to, I multiply the x in the both the side, I multiply x, so x into dou f by dou x equal to x into 3x square 3x cube, x into minus 4xy, minus 4xy means minus 4x square y, and plus x into 3y square means 3xy square. So this is a x dou f by dou x. This is the equation. I mark it equation number 1. Next I calculate the dou x by dou y. So that means we differentiate with respect to y. So differentiate with respect to y means on the both the side we differentiate the y. So dou f by dou y equal to, you see the first term there is no y, so differentiation is 0, and the second term minus 2x square, differentiate the y is 1, so minus 2x square plus 3x into differentiation of y square is 2y, so plus 6xy, definition of y cube is 3y square. Therefore dou f by dou y, here f will come, dou f by dou y equal to minus 2x square plus 6xy plus 3y square. So the next step I multiply y on both sides, so y into dou f by dou y equal to minus 2x square into y plus 6xy into y means 6xy square plus 3y square into y means 3y cube. This is the y into dou f by dou y. So this is the equation number 2. So now I add the, you see that this is the Euler's theorem. So I substitute x dou f by dou x value, y dou f by dou y value equal to, the right hand side I write it. So equation number 1 and 2, we add 1 and 2, so 1 plus 2 means dou f by, that means x will come here, x into dou f by dou x plus y into dou f by dou y equal to, so you see dou f, x into dou f by dou x, its equation is 3x cube minus 4x square plus 3xy square. Here 3 x cube will come. Okay, 3x cube minus 4x square y plus 3xy square. Next plus y into dou f by dou y. Y into dou f by dou y means minus 2x square y plus 6xy square plus 3y cube plus 3y cube will come here. This is 3y cube, not 3xy square, 3y cube. So the next step, so 3x cube, the next we add that means minus 6x square y minus 4x square y minus 2x square y. We add these two terms, we get the answer minus 6x square y. Next 3xy square plus 6xy square means 9xy square plus next 3y cube. The last term is 3y cube, not 3xy square. This is 3y cube, so I write it 3y cube. You see all the terms 3 is common, so I write that I take 3 in the outside. So 3 into x cube minus 2x square y plus 3xy square plus y cube. So this is the given functions f of x comma y. So this is a 3f. Therefore x into dou f by dou x plus y into dou f by dou y equal to 3f. This is our answer. We proved the given result. So this is the third problem. Prove that g of x comma y equal to x into log of y by x is homogeneous. What is the degree? Verify Euler's theorem for g. So you see, this is now I write it the given functions. Here prove that it is a homogeneous, and next they ask about the degree, and next verify the Euler theorem. So first I write the given functions. G of x comma y equal to x into log of y by x. So the next step, g of lambda x comma lambda y equal to, that means I take the x equal to lambda x and y equal to that means I substitute x equal to lambda x, y equal to lambda y. So lambda x into log of lambda x by lambda y. So lambda x into, now lambda cancelled, so therefore lambda into x of log y by x. Here x is the product, x of x into log of y by x. This is a given function, so therefore lambda into, here lambda power 1, not dash, lambda power 1, this is a given function. So g of x comma y, lambda power 1 g of x comma y. Therefore g of lambda x comma lambda y equal to lambda power 1 into g of x comma y means, so it is a homogeneous equation. G is a homogeneous equation. Its degree is n equal to 1. So now we verify the Euler's theorem. So by Euler theorem, x into dou g by, the given function is g, so I write it x into dou g by dou x plus y into dou g by dou y in equal to 1 into g, because the function is nf means, here n means the power. You see the lambda power means here the general value is, that means g of lambda x comma lambda y equal to lambda power n into g of x comma y. So n means the power of the lambda, so here the power of the lambda means 1, so n equal to 1. Here the degree n equal to 1, I substitute. In Euler theorem, the right hand side n means 1 into g, this is a g, not 9, this is a g, 1 into g equal to g. Therefore now we calculate that means x into dou g by dou x plus y into dou g by dou y equal to g. So now we verify that. So now first I calculate the dou g by dou x. We know that g equal to x log y by x. So dou g by dou x means the differentiate with respect to x on both sides. So dou g by dou x equal to, you see the x terms, x function is 2, so we apply the UV method. So UV method means first I write the x as it is, I differentiate the second functions, log of y by x whole dash plus log of y by x into, I differentiate the x first functions x dash. So next x into, now the differentiation of log is 1 by y by x. Next we differentiate the y by x. The differentiation of y by x means y into differentiation of 1 by x is minus 1 by x square minus y by x square plus log of log of y by x into differentiation of x is 1. So the next step, x square cancelled, y cancelled, therefore minus 1 log of y by x. So next x into dou g by dou x means we multiply the x on both sides, so minus x, here also x will come, plus x into log of y by x. Next we calculate the dou g by dou y. Dou g by dou y means here we write it, that means x into 1 by, that means we differentiate the dou g by dou y, we differentiate the log. So x into differentiation of log is 1 by y by x. Okay, next differentiation of y means we differentiate the y by x. Differentiation of y by x means 1 by x. So next x, that means we write it x square by y into 1 by x. So x cancelled, therefore x by y, therefore dou g by dou y equal to x by y. So next y into dou g by dou y, so we multiply y on both sides, so y cancelled, so y into dou g by dou y equal to x. This is the equation number 2. So 1 plus 2, so we add 1 and 2, we get the answer x into dou g by dou x plus y into dou g by dou y equal to, the equation is minus x plus x into log of 1 by x. Here log of y by x, not 1 by x, log of y by x plus x, minus x plus x cancelled. So this is the x into log of 1 by, that means x into log of y by x. This is the given functions. So this is the g, therefore this is the Euler's theorem we verified. We proved the Euler's theorem. This function satisfy the Euler's theorem. So fourth problem, if u of x comma y equal to x square plus y square by square root of x plus y, prove that x into dou u by dou x plus y into dou u by dou y equal to 3 by 2 into u. This is the given questions you see. So the given function is u of x comma y equal to x square plus y square by square root of x plus y. Now we will prove x into dou u by dou x plus y into dou u by dou y equal to 3 by 2 u. So first I write the given functions u of x comma y equal to x square plus y square by square root of x plus y. Now I substitute, that means I substitute u of, that means x equal to lambda x, y equal to lambda y, that means u of lambda x comma lambda y equal to, I substitute both the functions, I substitute x equal to lambda x, y equal to lambda y. So x square means lambda x whole square, so lambda square x square plus y means lambda y whole square, lambda square y square by square root of lambda x plus lambda y. So you see the see in the numerator lambda square common in all the terms, so I take outside lambda square into x square plus y square by, next lambda, I take the lambda from the square root, so lambda power 1 by 2 into square root of x plus y. So in the next step, u of lambda x comma lambda y equal to, that means we write it lambda power 2 minus 1 by 2. So lambda power 2 minus 1 by 2 means 4 minus 1 3 by 2, lambda power 3 by 2 u of, this is the given functions, that means x square plus y square by square root of x plus y. This is the u of x comma y. So we write it is this is a homogeneous conditions. Therefore from this we conclude that u of x comma y is a homogeneous functions of degree is n equal to 3 by 2. So now, so homogeneous satisfied means we take the Euler's theorem. So without satisfy we can't able to take the Euler theorem. Which function satisfy the homogeneous conditions, that function only satisfy the Euler theorem. So we take the Euler theorem conditions, x into dou u by dou x plus y into dou u by dou y equal to nf, nu. The n value is 3 by 2, I substitute 3 by 2 into u. Okay, so this is we proved our given result. So this result will be we proved, but now we proved in the equations this result, that means x into dou u by dou x plus y into dou u by dou y equal to 3 by 2 u. This is the answer for the given given problem. Next, fifth problem, we discuss about the fifth problem. If v of x comma y equal to log of x square plus y square by x plus y, prove that x into dou v by dou x plus y into dou v by dou y equal to 1. You see v is not a homogeneous function, so here v is not a homogeneous. So I taking exponential on both sides. So I write the given function v equal to log of x square plus y square by x plus y taking antilog. Antilog means exponential. So I take the exponential on both sides. So e power v equal to, that means e power of log. So e and the exponential log cancelled. So x square plus y square by x plus y equal to u. This is the, therefore e power v equal to x square plus y square by x plus y. So next u of lambda x comma lambda y equal to, now I substitute x equal to lambda x, y equal to lambda y in the functions. So here x square means lambda square x square, y square means lambda square y square by lambda x plus lambda y. So lambda square I take outside, lambda square into x square plus y square by lambda into x plus y. So in the next step, you see the lambda, divide the lambda square means lambda power 1 into u of x comma y. This is therefore we conclude that u of x comma y satisfy the homogeneous condition. U is a homogeneous functions. Its degree is n equal to 1 because the power of the lambda is 1, so n equal to 1. So now, so u satisfy the homogeneous function means we will able to take the Euler's theorem. So therefore by Euler's theorem I write the Euler's theorem, that means x into dou u by dou x plus y into dou x by dou y equal to, that means nu. N value is 1, so 1 u. So you see, that means x into here 1 u. Now we know that 1 v, so here v value is, so now in this step we substitute u equal to e power v. So x into dou by dou x of e power v plus y into dou by dou y of e power v equal to 1 into e power v. In the next step, now I differentiate the exponential. So x into e power v, I differentiate the power, so dou v by dou x plus y into e power v into I differentiate the power dou v by dou y equal to e power v. So next step, you see all the terms are e power v, so divided by e power v. So x into dou v by dou x plus y into dou v by dou y equal to 1. So next term, we know that v equal to log of x square plus y square minus log of x plus y. So dou v by dou x means we differentiate the v with respect to x on both sides. So dou v by dou x equal to, that means the differentiation of log is 1 by x square plus y square. Next differentiation of x square plus y square means differentiation of x square is 2x. So minus differentiation of log is 1 by x plus y. Next differentiation of x plus y is into 1. So therefore dou v by dou x equal to 1 by x square plus y square into 2x minus 1 by x plus y. So x into dou v by dou x, x into dou v by dou x means 2x square by x square plus y square minus x by x plus y. So this is x into dou v by dou x. Next to y into dou v, similarly I write it, y into dou v by dou y means 2y square by x square plus y square minus y by x plus y. So next we add the x into dou v by dou x, y into dou v by dou y. I add it. So the addition is 2x square plus 2y square by x square plus y square minus of x plus y by, here this is the denominator, by x plus y. So in the next step, 2 common, so we take the 2 in the outside, 2 into x square plus y square by x square plus y square. So this is a 1. So 2, and the next here x plus y by x plus y means the answer is 1. So 2 minus 1, this term not come, so this is not needed, so we just cancel this not needed. So 2 minus 1 means 1. Therefore x into dou v by dou x plus y into dou v by dou y equal to 1. This is our proof. We proved the result. We proved that x into dou v by dou x plus y into dou v by dou y equal to 1. So next we discuss about the sixth problem. If w of x comma y comma z equal to log of 5 x cube y power 4 will come 5 x cube y power 4 plus 7 y square x z power 4 minus 75 y cube into z power 4 by x square plus y square. Find x dou w by dou x plus y dou w by dou y plus z dou w by dou z. So here, so we will prove this equations. So w is not a homogeneous function, so w equal to, so log of 5 x y power 4, here y power 4 will come, plus 7 y square x into, that means 7 into y square x will come, x into z power 4 minus 75 x cube, that means minus 75 y cube into z power 4, here y cube will come, y cube into z power 4 by x square plus y square. So taking anti-log means exponential, taking exponential on both sides, so e power w equal to, the exponential and log cancelled, so 5 x cube y power 4 will come, right, y power 4 plus 7 y square, that means 7 y square x z power 4, here y square will come, so 7 y square x z power 4 minus 75 x is, that means y cube z power 4 will come, here z power 4 y cube z power 4 by x square plus y square equal to u. Now I substitute the u of lambda x comma lambda y comma lambda z. That means x equal to lambda x, y equal to lambda y, z equal to lambda z. I substitute in the above functions. So this functions I take u. So I take x 5 into x power 3. X power 3 means lambda power 3 x power 3. Y power 4 means lambda power 4 y power 4. So lambda power 3 lambda power 4 means lambda power 7. So 5 lambda power 7 x cube y power 4. 4 will come. So 5 into lambda power 7 x cube into y power 4 plus again. So every x, y, z we substitute, we get the answer lambda power 7 into 5. That means 5 x cube y power 4 plus 7 y square x z power 4 minus 75 y cube z power 4 by lambda square into x square plus y square. Now the lambda square divide the lambda power 7. So the remaining term is lambda power 5 into this the given functions 5 x cube y power 4 plus 7 y square into x z power 4 minus 75 y cube into z power 4 by x square plus y square. This is the given functions. That functions we take u of, that function is u of x comma y comma z. Therefore lambda power 5 into u of x comma y comma z. Therefore we see that from this we conclude that u is a homogeneous functions of degree 5. Therefore I write the Euler theorem. By Euler theorem, x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z equal to nu. We know that n value here, the degree is n, so n equal to 5. Therefore 5u. So the answer is this. The question is find x dou w by dou x plus y dou w by dou y plus z dou w by dou z. Now but we here from the Euler theorem we calculate x into dou u by dou x plus y into dou u by, here y will come, y into dou u by dou y plus z into dou u by dou z equal to 5u. Now we substitute u equal to e power w in all the u. So now I substitute all the u, I substitute e power w. So x into dou by dou x of e power w plus y into dou by dou y of e power w plus z into dou by dou z of e power w equal to 5 e power w. Therefore I write it. That means e power w into the, I differentiate the exponential e power w. I differentiate the power means dou w by dou x plus y into e power w dou w by dou y plus z into e power w means dou w by dou z equal to 5 e power w. So you see all the functions e power w is common, so divided by e power w. So x into dou w by dou x plus y into dou w by dou y plus z into dou w by dou z equal to 5. This is the answer. This is the answer for that means this is the required result. So this is so we find out the answer for the left hand side equations. So 5 is the answer for the left hand side of equations. X into dou w by dou x plus y into dou w by dou y plus z into dou w by dou z equal to 5. This is the answer. We find out the answer. We complete the class.